guys, what's up? Today I am covering installation testing of laparoscopic instruments. And any of us that have worked in a sterile processing department for any amount of time have seen a lot of these instruments, ranging from a prestige grasper to a microline applier, where we have scissor tips added to the distal tip, to a Maryland grasper, a trumpet suction, and so on. Most commonly, we can think of these instruments as coded. And why are they used? Well, they're used in what's called non-invasive surgery. So the entire purpose of a non-invasive procedure is to reduce post-operative recovery time and also to decrease the size of an incision or an open procedure. There are many benefits of laparoscopic surgery, but the whole point is to have it be non-invasive or less damaging to a patient. I think we can all agree that the reason we do anything is to add value to the patient safety environment. So a common step that I see gets missed is installation testing of every instrument after every procedure, every time, even if the instrument hasn't been used. When I used to work in sterile processing, which I did for 7 years, what I would find is that a lot of times the lap chole cases needed to be turned very quickly because the hospital only had about 10 to 12 sets, and they may have more cases than that in a day with add-ons, etc. So what I would end up doing is just saying, hey, 2, 4, 6, 8, 10, 12, every lap grasper is here, the stringer is good, everything is clean, we're good to go. And I would not test every instrument at every turn. But why I didn't do that is I thought that I was doing the department a favor by being more proactive and faster, when that wasn't really the answer. So if the goal is to reduce recovery time, what we need to ensure is that these devices are actually working properly during procedures. And that means that we are not going to have any breaks in this installation. So this particular instrument, a prestige grasper, this does not have heat conducted through it. But if we look at instruments like a Maryland grasper, think of Bovie post here. Bovie equals heat. So what's happened is that a Bovie is connected here and heat is conducted down the length of this instrument. Now, some would beg to say, hey, we don't have to test the prestige grasper because it's not in the IFUs. But the thing about current and electrosurgery is that energy jumps. So we may have more than one grasper and more than one incision. So a heat and a current can jump. So the point of insulation testing is that we don't want these little stray currents. I think of like little rays of lightning coming out. We don't want these stray currents burning unintended organs or areas. We want that heat conducted and coming out the distal tip to serve its purpose, whether that is to desiccate, whether that's to remove polyps, whether that's to create space. That being said, in a laparoscopic procedure, the abdomen is inflated with carbon dioxide gas. This gives your surgeon more room to work and a better visual clarity. So sometimes, I didn't know this until I was watching procedures, but there's this little cup here on some of the instruments. Is it necessary that it's there? Yes, because air can be released out of the abdomen if there is no seal happening here. But I will get to the insulation testing itself. So how do you insulation test an instrument? Again, every instrument, every time. Every department will have a different type of insulation tester. I'm not here to promote what kind of insulation tester you're using. I'm just promoting that it happens from a patient safety perspective. So most insulation testers will have an alligator clip. This alligator clip needs to be grounded onto something metal. So let's say we can ground it on the Bovie post, which I recommend checking. Is this loose? Is it moving? And is it working? And then follow the manufacturer's IFUs for whatever insulation tester you do have. So on this one, I'm holding down the button and you hear a beep. That's because there's metal right there. And then you go the length of it. I go slowly. On this one, I will draw up and then I will push down so that it's going the whole length and it hits the top and the bottom of this instrument. What I recommend is that you just do it the same way every time so you don't have any misses. And then for instruments like this one, the handle is coated as well. What do I recommend? Insulation testing the handle as well. Sometimes this requires a different testing unit. In this case, I have this. And what you do is you go the outside of the handle, down the length. You hear a beep there because that's where the set screw is. That's not a problem. Right here, down through the inside, and then on the insides here of the ring handle, you'll hear that beep again. Why do we insulation test the handle? So we don't shock the surgeons, because heat does travel. So that is very important as well. So you do the same for every instrument. Test the handles, test the length of the shaft, and then another very important step is to ensure that these are working properly. So if it's roticulating, is it moving? Thank you.
You have to make sure they work.
What's that?
You have to put them all together after they come back.
Yep, well, I'm not putting them back together, I'm just ensuring that they're working.
Oh, there you go.
I'm insulation tested. So that's real life, my friends. Working in a hospital, people are always in it and asking questions, which is why I love to do education, because you can help explain to people what you're doing and why. So I digress. So make sure that the roticulating mechanism is working on these, and surgeons are usually holding with one hand. I don't do that as well as a surgeon, but we'll just roticulate with one finger and one hand. And then is it manipulating the distal tip? Now, when we get down to the distal tip of this, we see that it flares a little bit. Make sure that these working elements are in place and working. Of course, make sure there's no bioburden in the different serrations of the tip, and make sure that when the handle is used, it is manipulating properly. We can move to the Prestige Grasper. Again, a controversial topic in terms of whether this should be insulation tested or not. I am of the strong feeling that it should be, because as I expressed before, currents can jump. I'm sure I'll have an Aesculap rep jump on here and tell me otherwise, which I love the conversation starter, so let's do it. So we do the same with the Prestige Grasper or any other instrument. Is the tip working? On this one, is the handle locking as it should? When it's locked, is it holding? That's important. And then assessing it for the quality of the last repair. Does this insulation come all the way to the proximal end here and then go the length of the distal tip? Meaning, is it flush all the way to the end here, or is there metal exposed? So these are all important inspection steps. I'm not going to go much further. We check the handle, we make sure this bovie post is in place. This one moves a little bit, but it's still firm and solid. It's not coming out. I see it come out a lot. We check the length of the shaft. We make sure the working mechanism is good. Now you can check these with just your eyes, but you'll have better luck using an insulation tester because it catches that stray energy. And last but not least, commonly missed insulation tests that I see would be your bipolar forceps used in neurosurgery and in pediatric surgery. These instruments should, first of all, be evaluated, like how much damage is to the distal tip. Is there a lot of dents and dings on this? This one is looking great. And then you do the same process. You ground it to something metal, and then you run the length of it on the inside, on the outside. I already know that this one has failed and it needs to be re-powder coated. That's it, my friends. But I see it so often. Not every instrument is tested every time, and it is very, very critical to patient safety. And right now, as we all know, we have a lot going on in our industry with the coronavirus and everything going on, but our job in sterile processing and our job as vendors is to continue to educate, continue to bring patient safety and awareness levels higher, and doing our daily practices the right way. I hope you guys found this video helpful and that everyone has the best day. Bye.